Ideas about mechanical thinking go back to Aristotle and later philosophers who wondered how reasoning works. In the 19th and early 20th centuries, thinkers like George Boole and Kurt Gödel built mathematical logic that made computation possible. Alan Turing formalized computation and in 1950 asked the seminal question, can machines think? AI as a field was born at the 1956 Dartmouth Conference. John McCarthy coined the term artificial intelligence. Early programs like Logic Theorist and the General Problem Solver showed machines could reason in limited domains. There was intense optimism. Many thought human-level AI was only decades away. But limits in compute and overpromised systems led to the AI winters. Funding collapsed in the 1970s and again in the late 1980s when expert systems failed to scale. Progress stalled while researchers rethought approaches. The revival began as compute, data, and new algorithms converged in the 1990s and 2000s. In 1997, IBM's Deep Blue beat Garry Kasparov, a milestone for applied AI. Then machine learning and later deep learning began replacing rigid rules with models that learn from data. 2012 was pivotal. AlexNet beat competitors on ImageNet and ignited the deep learning revolution. Since then, advances in GPUs, data and models accelerated capabilities in vision, speech and language. Research entered an era of rapid iteration and broad deployment. So the history of AI moves from philosophical roots to early programs through winters and into a data-driven renaissance. That groundwork sets the stage for how AI is embedded in our world today. Today we're in an AI explosion. Compute, data, and algorithms aligned to drive rapid change. AI scales across every sector and at global speed. This affects research, industry, and daily life. Core technologies start with machine learning, statistical models that learn from data. Deep learning uses layered neural networks to extract patterns at scale. These power speech, vision, and language tasks across consumer products. Natural language models like GPT, BERT, and Llama enable comprehension and generation of text. Computer vision identifies images, faces, and medical anomalies with growing accuracy. Robotics combined with AI drives automation in manufacturing and autonomous vehicles. On the consumer side, voice assistants, recommendation engines, and personalized feeds. In business, marketing automation, fraud detection, and supply chain optimization. In healthcare, diagnostics, genomics, and drug discovery are transforming treatments. AI brings productivity but also disrupts jobs, especially routine roles. Bias and fairness are real problems when models learn from biased data. Privacy, deepfakes, and surveillance raise ethical and governance challenges. Nations compete over AI infrastructure, talent, and regulation. Educators and students must learn not just tools but ethical use and governance. The present is powerful and messy. Innovation and responsibility must move together. Short-term, AI becomes ubiquitous. Education, health, finance, and even warfare will see deeper integration. Autonomous vehicles and delivery drones edge toward mainstream deployment. Personal AI assistants grow more personalized and proactive. Expect stronger AI governance, rules, standards, and international treaties may emerge. Augmented intelligence will pair humans with AI for better outcomes, not just automation. Education will see adaptive tutors and lifelong personalized learning. Midterm, researchers debate the arrival of AGI, systems with broad human-like cognition. Human-AI symbiosis, including brain-computer interfaces and digital twins, becomes plausible. AI will enable autonomous exploration, robots on Mars and automated resource missions. Large-scale automation could displace jobs, prompting talks about universal basic income and new social contracts. Policymakers, companies, and communities must coordinate transitions. Reskilling and education are essential to share benefits widely. Long-term visions include artificial superintelligence that could exceed human capabilities. The key risk is alignment, ensuring AI goals match human values and safety constraints. This raises philosophical questions about consciousness, identity, and purpose. Practical risks include misuse, concentration of power, and systemic failures. Mitigations require technical safety research, regulation, and public engagement. Open research, transparency, and global cooperation reduce single-point failures. The potential is immense, curing diseases, solving climate modeling, and expanding human reach into space. If governed well, AI could create abundance and lift global living standards, but benefits depend on choices we make today. History brought us from thought experiments to deep learning. Today, AI touches everything. Tomorrow depends on governance, ethics, and innovation. For students and educators, learn the tech, study its impacts, and help shape responsible AI. AI is a tool that can uplift or harm, the trajectory is ours to steer.